One thing most people believe about rare gemstones is this. If a stone is valuable, it should look valuable the moment it comes out of the ground. Clear, bright, impossible to miss. If you still believe that and throw aside every dull or dirt-covered rock, you may be discarding the one specimen that deserved a closer look. Today, we are going to dismantle one of the most expensive assumptions in rock collecting. We will uncover the physical signs that can separate an ordinary stone from a possible gem-bearing specimen. By the end, you will know what to notice, which popular tests can fool you, and what never to do when several clues appear at once. Because a rare gemstone does not always announce itself with beauty. Sometimes it announces itself by behaving differently. The myth probably began the first time you saw a diamond ring or an emerald beneath jewelry store lights. Every surface was polished, every edge had been cut to return light toward your eyes. Your brain created a simple rule: diamonds sparkle, ordinary rocks do not. But a natural crystal may spend millions of years being fractured, stained, coated in clay, and battered through rivers. Nature provides the material, humans reveal the shine. There's another confusion to clear up. Finding a gem mineral and finding a valuable gem-quality specimen are not the same thing. A rock may contain corundum, the mineral behind ruby and sapphire, but be too opaque or fractured to cut. Identification asks, what is it? Value asks, what can be done with it? First, we need to know whether the stone deserves that second question. Start with light, not sparkle, light. Mica flashes like tiny mirrors. Pyrite can shine like gold. Broken glass may look more brilliant than rough sapphire. Dry the stone and place a strong white flashlight against a thin edge. Does the light die at the surface, or does the material glow from within? A crystal may be opaque through its center, but translucent around a chipped edge. That's not proof of a gemstone, it's a reason to stop treating it like an ordinary rock. Now turn it slowly. Some minerals reveal bands, patches, or cores of color created as their chemical environment changed during growth. Tourmaline can develop dramatic zones. Other crystals appear lighter, darker, or slightly different in color from another direction. Surface staining usually collects in cracks or coats one side more strongly. Use water and a soft brush. Acid, bleach, and wire brushes may erase evidence before you understand it. Take a closer look at the shape. One flat surface means nothing. Rocks break, glass breaks. What matters is repetition. Several faces meeting at consistent angles, parallel grooves, or symmetry continuing beneath the weathered crust. Quartz and beryl, the family containing emerald and aquamarine, can grow as six-sided crystals. Garnets often form compact shapes with repeated faces. Corundum may appear barrel-shaped or bipyramidal. Why does geometry matter? Because a crystal's atoms follow an ordered internal structure, and that invisible order can control the shape outside. A repeated angle is the mineral following instructions written at an atomic scale. Weathering may damage those instructions, but it rarely erases every trace. Even a rounded creekstone can preserve one growth face or a set of parallel striations.
Then pick it up. Does it feel strangely heavy for its size? Your brain predicts weight before the stone reaches your hand. When that prediction is wrong, density may be telling you something. Quartz has a specific gravity of about 2.65. Peridot is around 3.34, diamond 3.52, spinel 3.60, and corundum close to 4. But common metallic minerals can be heavier. Unexpected weight begins an investigation. It does not finish one. Gemologists can compare a stone's weight in air with its apparent weight suspended in water to estimate specific gravity. But matrix, cracks, porosity, and trapped bubbles can distort the result. The internet loves one test, one number, and one instant answer. Real identification requires every useful clue to agree with the others. Hardness creates the same problem. People hear that gemstones are hard, grab a knife and scratch the best surface. Hardness means resistance to scratching, not breaking. Quartz ranks 7 on the Mohs scale and scratches glass. So do millions of ordinary quartz pebbles. Opal is softer than quartz and can still be valuable. Passing the glass test does not make a stone precious. Failing it does not make one worthless. Never confuse damaging a specimen with identifying it. Now look inside with a hand lens. Something that appears flawed may suddenly become more interesting. Tiny crystals, needles, clouds, healed fractures, cavities containing liquid or gas. These features are called inclusions, and they can preserve part of the stone's growth history. The imperfection you wish were absent may help an expert determine what the material is or whether it formed naturally. But here another myth appears. Bubbles always mean fake glass. Manufactured glass often contains rounded bubbles and curved flow lines, but natural gemstones can also contain fluid inclusions with gas bubbles. One bubble proves almost nothing. The complete pattern matters. A magnifying glass may reveal the mystery without being powerful enough to solve it. Switch off the room lights and another clue may appear. Under ultraviolet light, some diamonds fluoresce blue. Chromium-bearing ruby can glow red. Other minerals produce green, orange, yellow, or no visible reaction. A glow reveals something about impurities or defects in the crystal structure. It does not reveal a price. Common minerals can fluoresce beautifully, while valuable gems remain dark. Fluorescence is one fragment of a fingerprint, not the entire identity. So far, every sign has been on or inside the specimen, but one of the strongest clues may be on the ground around it. Coarse-grained pegmatites can host quartz, feldspar, mica, tourmaline, beryl, and topaz. Volcanic and metamorphic environments produce other gem minerals. Rivers break down these sources, transport durable crystals, and concentrate dense material inside gravel traps and cracks where the current loses energy. A green pebble from imported landscaping gravel has almost no geological biography. A similar crystal found beside matching fragments, quartz veins, mica, feldspar, or dark sand, tells a stronger story. Was it loose or attached to matrix? Rounded by water or sharp from a nearby source, alone or repeated across the area? Photograph the location before moving anything and confirm that collecting is legal. When the location is forgotten, part of the specimen is lost.
Now you can see the psychological trap. Some people reject every ugly stone because it does not resemble jewelry. Others find one colorful pebble, fall in love with the idea of being rich, and interpret every flash and scratch as confirmation. These reactions look opposite, but both make the same mistake. They decide first and investigate second. A disciplined collector delays the exciting conclusion. The goal is not to prove the rock is a gemstone. The goal is to eliminate ordinary explanations. Quartz can transmit light, form beautiful crystals, scratch glass, and show valuable-looking colors. Slag may be bright blue or green with glossy fractures. Mica glitters but separates into sheets. Pyrite forms impressive cubes and shines like gold. Nature produces convincing imposters, and humans produce even more. Even when a specimen contains ruby, sapphire, emerald, or tourmaline, value is not guaranteed. Transparency, color, fractures, size, durability, treatments, and clean material available for cutting all matter. The word gemstone describes potential. It does not print a dollar amount onto the rock. So, what should you do when several signs align? Less than your excitement tells you. Do not smash it open. Do not grind away the surface or soak it in chemicals. Photograph it dry and wet from several angles beside a ruler or coin. Record the date, exact location, nearby minerals, and surrounding rock. Wrap it separately so harder materials cannot scratch softer ones. Then let someone with the proper tools challenge your conclusion. A mineral club, university geology department, qualified gemologist, or reputable laboratory can examine properties a photograph cannot capture. Professional identification may involve microscopy, refractive behavior, specific gravity, spectroscopy, and chemical analysis. The purpose is not to confirm the story you want, it is to discover the story the specimen can support. The next time a dull stone behaves in a way an ordinary rock should not, stop. Does light enter its edges? Is the color internal rather than a stain? Do its faces repeat a crystal pattern? Is its density unexpected? Do the hardness, inclusions, fluorescence, and locations support the same possibility? One sign can fool you. Several independent signs pointing in the same direction are how a real discovery begins. You may still be holding quartz, glass, slag, or a mineral with no cutting value, but you will no longer judge it by the myth that treasure must already look like treasure. Rare gemstones are missed because most people were trained to recognize the finished product, not the natural evidence. If this video changed the way you examine the rocks around you, leave a like and subscribe to the channel. Here we uncover the geological clues, hidden minerals, and natural materials most people walk past without noticing. And tell us in the comments, what is the strangest stone you have ever found, and which of these signs did it show? Your answer may give another collector the clue they have been missing.